say, from a rather small organization, various computer history perspectives. It's me and Jeannie Treichel, both from Sun Microsystems. And we're small, but we were first in that we started having history talks about 4 years ago. And now that the Computer Museum History Center is here, it's only natural to join forces and put these talks together. And we, in our history series, we had talked where we have history all around us. And I'd like to say that the whole history center, oh, computer history, community artifacts was the nucleus for the Computer Museum back in Massachusetts. Quarters in Marlborough, outside of Boston, back in 1983. And I think we can all appreciate this. So, Gordon, I'll let you introduce the other presenters today.
Okay. Actually, you're right, is Avram Miller, who's a Vice President at Intel now, and was one of the conspirators in the DEC being in the PC business or not. And then far right is Barry James Paulson, who was responsible for the 80, and then 8088 original Intel-based PCs. Avram was building a PDP-11 based PC called CT or Pro, or it had many names. It started out as KO for auspicious reason. Had no relationship to Ken Olsen, the founder, of course. It was to be Knockout. Anyway, so you have here I'd say maybe two of the four conspirators in DEC, not DEC's early positioning in the PC business. My boss at the time, Ken Olsen, said, his famous quote is, "Who would ever want a PC in the home?" And I don't remember when he said it, but he did. Said it to us many times. This was after I wrote a memo in '69 at Carnegie, where a number of us were experimenting with computers at our home. So we forgot to tell him about it for 10 years. But certainly Ken would never want a computer in his home. The scenery that we've got here goes up until the period of '84, so it covers that era of starting the PCs, and sort of to set the stage at this time when we introduced the Pro or the CT or the PDP-11 and the Rainbow. There were three, and then the PDP-8, which was a thing called DEC-8. It was a second version of a PDP-8 machine for doing word processing. It was it followed a lot of the philosophy of DEC at the time, which was don't put all your eggs in one basket. Find any basket you can and put an egg in it. I'll plead somewhat innocent to all of this because even though the person, Dick Clayton, who was not here, was in charge of the various, we call them low-end machines, was doing that. I was concentrating on building another computer called the VAX. And I'd say the main benefit of the PDP-11, or of all of these efforts in the PC era at the time, was that we had absolutely no interference or comments from Ken on VAX. Ken had nothing to do with it, and so these were the PCs we can look at as maybe a diversionary effort for Ken. Otherwise, VAX might not have saved the company long enough to be attacked by later on by the Unix and the subsequent PC revolution. So we had a meeting we talked the other evening at dinner, and we all kind of concurred about what to look for in all this. But I think what we want to do is start with a famous tape that was made by Marc Porat. Is Marc here? I hope. Marc Porat, whom some of you may know, is not the famous photographer Marc Porat, producer, took on another life as the founder of General Magic. Anyway, Marc produced a film that was chronicled the effort, and so what we'll show is some video of that era, and then we'll go into the rest.
Yeah, I'm going to introduce the videotape, and you're going to see excerpts from two videos. One is called Personal Challenge. This is a tape that does not exist, so there's no copyright violation problems. The other one, this was from the period 81 to 82. The other one is a speech that I actually gave in DEC in 84 about why IBM won and DEC lost. So from perspective in 84, what we thought had happened to DEC. While watching the first one, Personal Challenge, I want you to point out a couple things to watch for. Watch for DEC's culture and mindset. It just permeates the whole tape. Also, what's missing is no conversation whatever about third-party package software. I'll also point out there's Jerry Davis, who's a lawyer down in Monterey, who told Dorothy Kildall when IBM came calling on Digital Research not to sign the contract, and IBM went back up to Microsoft and got DOS. So I'll point him out in the tape. And also look at the conversation goes on. Who is the competition DEC is most scared of next to IBM? So watch for that. The second tape is called PC Friend or Foe. Is it a friend for DEC or is it a foe for DEC? And what that will do for you is contrast within DEC the difference between the mini computer business and the PC business. And also in a very brutal way, it will contrast DEC's culture versus IBM's culture. In the very end, you'll see some very subtle things. You'll see pictures of the annual report covers of IBM and of DEC contrasted at the end. And this will take about 25 minutes.
Untold personal story of dedication, frustration, and challenge. This is one story among many. All right, let's get started right away. With that being up on you, approved by
when you're not number one, you don't control things, and that's no fun. It's fun to be the leader. And we're the leader of mini computers. We have 38% of the mini computers, and we want 38% of the personal computers, or 40%, or whatever it takes to be number one. And in that marketplace, that means build a business that would be by 1985, fiscal 85, $3.5 billion. The plans are currently to build over 120,000 small systems the first year. And in the home computer marketplace, where he doesn't really do a good job, then the Japanese will walk away with them. And believe me, we can't let that happen. I mean, we absolutely can't let that happen. The American public ever gets in their head the idea that the Japanese make a better product. Once they believe that, you're finished. You know, we only are successful if every person here is committed to making this program successful. Because every one of you has an opportunity, almost every day, to make a major difference in the program.
Personal computer market is the biggest single market in the world today. And to understand that, you've got to understand that information and the movement of information is the single biggest market in the world today. Presently in the United States, we're spending about half of our GNP merely at handling, moving, changing, processing information. The personal computer is the doorway into that market, is what's going to allow people to converse better, to handle information better, to do their jobs better. So if you ask how big the personal computer market is, you really have to ask how big is the economy, how many people live here, how many people are going to work.
In 1957, a team of 3 engineers at the Massachusetts Institute of Technology designed a revolutionary new computer, the TX-0. One of those engineers, 30-year-old Ken Olsen, was inspired by the experience. With $70,000 and an idea, he founded Digital Equipment Corporation. The PDP-1, Digital's first computer, launched a virtually unbroken string of technical and financial successes. The PDP-6, a timesharing computer created by 4 engineers, including Gordon Bell. The PDP-8, the world's first mini computer. The popular PDP-11, still the best-selling mini computer ever. By their 25th anniversary, Digital had become the world's second-largest computer company, with 68,000 employees working in 39 countries and 5 continents. But after all these achievements, Digital still had not entered the personal computer battle.
It was clear that we had an obligation to make a major commitment to the personal computing. We have experience in just that area, which no one else did. We understand how it fits in to many areas of life better than people who have made thousands of them. It was so clear we had an obligation to do it. We had the resources and the technology. It was just clear we had to do it.
Every year, Digital develops dozens of critically important new projects. People working together are the essential ingredients of success. One such team of people was the CT Group. Ron Ham, in charge of software. Michael Weinstein, merchandising. Art Williams, hardware. Var Erdikian, manufacturing. Avram Miller, project manager. A small business within a large company, a microcosm of what Digital is all about, as a company and as a culture.
If you had asked me in the beginning of the program what the chances were of succeeding, I'd say probably less than 30%. And I really picked people to work with me that were willing to take a personal risk. In fact, I told each one of them, I said, you know, you should assume that, that there's a good chance we won't succeed.
Trying to do with computers is to make a machine that in fact is so good that in fact it can be a intellectual companion with humans. And so that, you know, just trying to do that is so hard and so intellectually stimulating that
That's really what keeps the industry always moving and always vibrant.
An engineer is a very creative person. He's totally motivated by challenge and creativity, doing something generally that hasn't been done before. They will give you more than your 100% effort if you simply show them that you trust them, believe in them. When there's elegance, it's there. There's no doubt about it. Elegance, it works. It's just the best.
If we're successful at a personal computer, it'll be easy enough to use that it'll be natural. You never notice the curvature of a hammer. The handle of a hammer took years to develop, or a hatchet, an axe. You don't notice it. It feels good in your hand. No one will notice that it works well. If it's clunky, if it doesn't fit, if it requires the user's mind to go down a path that the user doesn't normally go, it will be declared computers. Programming is a lonely art. You're by yourself. You're trying to create something from nothing. So it's just as easy to create in the wee hours of the morning. And they have this tremendous need to build the best, to stretch themselves. I've seen programmers rewrite what I thought was perfectly acceptable coding because it was somehow better. They had a vision or an abstraction of what was slightly better. They need to create. They simply want to create something from nothing. You can't see software. You can't photograph it. You know when it's broke. You barely notice it when it's working well. But the programmer knows he's created something from almost nothing. There's something about him in that, or her in that code.
Pressure. And the pressure is in the form of a responsibility. There's a feeling of an urgency. There's a feeling that if we are not able to make a penetration in this market within the next year or two, it becomes more and more difficult. The other people become entrenched. There's a second consideration. We digital are more a culture than we are an organization. It is our ability to turn into a new direction. And insofar as people in the CT program feel a responsibility for pinpointing that move or providing a new direction, then we carry a cultural responsibility. I think to understand the CT program, you have to understand those two dimensions. One, the fear of failure. The other, the exhilaration of possible success.
March 1982. The CT group has been pushing hard for over a year. The personal computer still doesn't work like it should. Stress and exhaustion are taking a toll on the whole group. A psychiatrist visits one day.
I've been involved with you now for almost 18 minutes, and I'm exhausted.
I think you're under too much stress.
You'll get past. We'll give you credit for perception.
There's tension.
Probably the biggest danger, biggest human weakness, comes about from a few years of success. It blinds us, it blinds anyone. Pride, probably the biggest human weakness.
All right, so let's speak to the point of how IBM can clean our clocks, or how Japan can clean our clocks, and what we're going to do against it. I mean, I don't want to drag this meeting down to a bummer, but tell me.
Are we going to lead, or are we going to follow here?
Why don't we, instead of waiting for what they do, why don't we put a strategy together that lets them play catch-up?
Really, no matter what we look at, the Japanese, everything is lower and the quality superb. Everything.
I mean, if I were to be out there competing with us, I wouldn't try to compete with us in the Fortune 1000, because we have that, right? So where we're vulnerable is the fact that we haven't figured out a strategy for the small business.
I feel more comfortable, maybe I'm just psychologically more comfortable doing something than sitting back and waiting for them to drop it on us.
Well, no, but what we're doing is trying to build the best possible products. Okay? I mean, what would you like to do? Do you know a better way to build a better product? Then we should be building it, irrespective of IBM. Because if it's not IBM, it's somebody else, see?
Anyway,
Yeah, I leave with an uncomfortable feeling.
What do we do?
Yeah, what do we do?
On behalf of all of us at Digital, I would like to welcome the 300 journalists from the 15 countries who have joined us here today in Boston and via satellite link-up in London and Toronto.
This set of projects has created more enthusiasm, more fun, more excitement in the company than I've ever seen before. Now we think we have a set of products that have all the features that we've ever wanted in the machines.
But even as the video conference beams to the world, they know that this is only a media event.
One wire plugs behind the monitor.
In the last month, 4 other computer companies announced their new personal computers. And as of today, Digital has only 50 working models of their personal computer.
Good things. And either way, we'll supply the equipment. But we're not aiming toward that. We're not dependent on that market.
The real work is still ahead.
Somewhat serious computing, if there's bright children.
Damage the project, and they knew it.
The toughest task we have ahead of us now is to integrate our 6' manufacturing plants and get them all together to work together with the half a dozen secondary plants where we have to put together our manufacturing strategy and build the highest volume product we've ever done before.
It was a new world, and the adjustments weren't easy. June 2nd, new automated machines are brought in. Manufacturing is gearing up for the personal computer.
Good morning. Welcome to the National Computer Conference and to Digital's Office Plus exhibit. Today we're introducing many exciting and new products.
I think this machine is going to be one of
Jerry Davis.
And here we are with a booth of new products, and we've got to be number one.
Digital's personal computer is the hit of the show, a tremendous success. But typically, the project people are restless, worried. They've got to check out the competition.
Ooh. Oh, ooh, ouch. That's impressive. At least on the surface. Yeah.
I mean, I bet you they have
All kinds of new goodies. Go on up and take a look.
Oh, super.
68,000.
another 68,000.
256 KB of memory and a NEC 7220 chip.
Good, it's good stuff.
Yeah, this is good stuff.
What do you think of that stuff?
I think they're the best. Fortunately, they're small.
Yeah.
It's not something that's actually plugged in yourself.
I don't understand why people put on and off switches in the back of things. You never forget that.
Very powerful unit, very expandable, very flexible.
Okay. It's a Help King?
Yes, a Help King it is. We have 5 function keys, which can be...
So far so good, providing we don't get carried away. I'm amazed. Cautiously optimistic.
Now what you did with the parking meter last night? No, it expired.
I'm still amazed that the big guys did not do better.
I'm kind of underwhelmed about the competition. I mean, I really expected something.
Yeah, I expect something too.
It's sort of disappointing in a way.
If this was supposed to be a war, it was depressing. And it was supposed to be a war.
We went from being nobody to probably considered to be one of the top couple.
That's right. We now are the only people in the world out there with a 3rd generation system.
That's right.
I'm happy we did it. I think a lot of people, I'm better for it. A lot of people are better for it. On the other hand, I don't know. I don't think people understand what we did or tried to do, and so I guess I feel very disappointed.
I think most of the people in the group have had a very powerful personal experience. And it's possible for them to think that it never happened. When it would go away. And I hope that they don't lose that.
I want to welcome everybody who...
Right now, there's several tremendously creative projects going on. The personal computer, that's one. Now we go on to others. Each one is a danger. Danger that we're not bright enough, danger that we don't see it correctly, danger that someone gets there earlier and does a better job. But then life is filled with danger. What we do today, tomorrow sounds old. Tomorrow, there'll be a new challenge.
I would talk about a more provocative subject. I would talk about personal computers. Are they our friends or are they our foes? I know in the back of all of our minds that personal computers have not lived up to our expectations, and we're questioning maybe why did we ever get into this business, and do we really want to be involved in this business? IBM on September of '81 introduced the personal computer. It was the first 16-bit personal computer in the market from a major manufacturer. They had the entire market to themselves for 12 months. It took 12 months for the next competitor to enter the market. When the IBM PC was announced, it only had 3 applications and a couple of games, and believe it or not, when the IBM PC was announced, it only had 3 applications and a couple of games, and believe it or not, they targeted for, of all places, the home computer market. And damn it, the product moved upscale on them, and they found themselves in the business and professional market. And in October of '83 of this year, in Business Week, we see the following headline. In October of '83 of this year, in Business Week, we see the following headline, that the winner is IBM. Why have PCs not met our expectations? Why was IBM so successful? I believe one of the reasons was that IBM realized that the PC business was different from their traditional business, that it was not an extension of the business that they were in. It is 2 different businesses. What makes you successful in one won't necessarily make you successful in the other business. The point here is not to look at the traditional business versus the PC business as right or wrong, black or white, but it's really not even gray. They are just different. And it's not the traditional business versus the PC business. They are just 2 different businesses. The important knothole to get through is that they're not the same. And once you get through that knothole, you begin to unravel the phenomenon called the PC phenomenon. I'd like to give you some pictures of our traditional computer leaders. First, John Opel from IBM, and of course, our friend Ken. I like to contrast these 2 leaders with some personal computer leaders. And here are 3 out of several. On your left, the bottom, Bill Gates, 28 years old, chairman of Microsoft, growing to a $100 million company this year. Next to him on the bottom right, someone called Steve Jobs, whose age is also 28, started Apple in his garage, is now a $1 billion company. And Mitch Kapor, top right, unfortunately he's not in his 20s anymore, he's not in this league, he's now 31, he is president of Lotus. And they are a $35 to $45 million company. Now I'm beginning to contrast the difference between the traditional business and the PC business, and you're going to say, aha, I get your point, Barry. There's an age difference.
reason about the PC phenomenon. What is significant is that these young gentlemen, unfortunately for most of our perspectives, are filthy rich. Now, since they are filthy rich, there are literally thousands of people wanting to write the next hit record so they too can become moderately rich. Now, when you have literally thousands of people attempting to create that next hit record, the law of large numbers says one or two will succeed. So what these gentlemen reflect is a drive and an emotion in people to go for that brass ring. And part of the PC phenomenon is there are a lot of people putting a lot of energy in writing software for the IBM PC. Let me go through a list of some of the differences, and they're somewhat obvious. Traditional business, multi-users, PC business, single users, $15K for the traditional business. PCs, we see $2,000 to $12,000 as the price range. Traditional business, powerful, versatile, and best of all, complex. And the PC business, Peter Conklin indicated, easy to use, simple, and also small. Now let me show you graphically the differences between complex, simple, and small. First, I start with a picture of a Ethernet transceiver, also taken apart. This is obviously very powerful, very versatile, very complex. Phil Stricker spent a whole half hour explaining this to you. I would now like to show you what I call OI, OmniNet. I am concerned about the Japanese penetrating this market. Businesses are different, but the technology is not different. And that's what leads us to be confused about the businesses being the same, because we believe the technologies are the same. The technologies are the same, the businesses are different. Problems is our image. In our Fortune 1000 study by ADL, we found out that the IBM image in the marketplace was a security blanket. You don't ever risk your career by choosing IBM. IBM has the ability to serve the great majority. And IBM understands user needs. On the unfavorable side about IBM's image is that they're not a technical leader and that they're expensive and premium priced, and parenthetically, these people are very willing to pay that price. On the other hand, in this Fortune 1000 study, DEC's image came across loud and clear with a strong identification with the scientific and technical marketplace, and a strong identification with good quality product that's well engineered. On the unfavorable side, we are not known as a business computer manufacturer. Now we've got to talk about the difference between perception versus reality.
Of course, at the end were the annual reports. On the left-hand side was IBM's, and on the right-hand side was Digital's. And I think those two covers of the annual report speak volumes, and one of the reasons why we're here.
So here we are, relics amongst the relics. And I think we're going to comment a little bit about the experience. First of all, one of the people that was involved in the program is here in the room, Jeff Roudier. Why don't you?
Yeah.
He went through it with us. It was pretty amazing, and I don't know, the film that was kind of cut and edited, you can't get all the feeling of it, but those of us that were in this program actually did get a lot out of it. And I personally grew a great deal and learned a lot. Some of the things I learned weren't pretty, and so they were difficult things to deal with. One of the things that was that technology
wasn't really the basis of the business going forward. We probably engineered everything. We were discussing, Barry and I were discussing at dinner whether or not we redid the power cord. He was shocked to find out that we had. There wasn't one piece of the system that we didn't invent. You know, new connectors, new packaging, new keyboards. We had a whole committee working on the keyboards for about a year, trying to figure out where to place the keys and the touch and the feel of the keys. We wanted to provide the best possible engineering, and the people that were in the program, primarily dominated by engineers, really were committed to building wonderful products, both in the Rainbow group, the DECmate group, and in the Pro group, the CT group. Some of the most creative and motivated engineers in the world were, and software and hardware, were working on this program. But as it went through, and I think one of the things I began to realize, and I mean, I was shocked by the fact that the IBM PC was doing as well. Incidentally, it was doing wonderful, but it wasn't doing wonderful for IBM. The IBM PC was basically a virus turned loose within the body of IBM, and did as much damage to IBM as it did to DEC or to anybody else. But the product was doing great, and our products weren't doing very well. And but as I started seeing the IBM product succeed, and the first time we got one, you know, we had one, actually, Ken Olsen and I got a hold of one. We have a note here about it, which says, "Dear DEC, good luck. If you need any help, let us know, IBM." Ken said to me, you know, as we took it apart with screwdrivers, he was very interested to look at the power supply. Ken, being originally a power supply engineer, said, you know, if we ever build, any of us would try to build a product as poor as that, we wouldn't be a DEC, and that was probably true. We've probably been in Silicon Valley being multi-billionaires, but you know, we didn't understand the notion of adequacy. We were looking for superb products. But as time went on, I would just relate one conversation I had with Ken, which is probably the most meaningful one from my history, was I said to Ken one day, we had a little argument, and I said, you know, Ken, we have to have a good product and great marketing. And he says, no, Avram, we have to have a great product and good marketing. And we went back and forth on that, and finally he says, but you don't understand, we can't have great marketing. We're incapable. So we better have you know, a great product. So that was you know, very interesting perspective here. But I think that we were talking about, you know, how we blew it, and I guess the question that we all should have is, could we have ever won? And I think that generally we couldn't. No one could have won. Something else was driving this, and it was a change in the way technology would be delivered. It was a change from a vertical industry to a horizontal industry. And the people that were really behind this whole revolution, they didn't even know they were behind it, were the component suppliers. You know, Intel, where I'm now, didn't know it was behind this revolution, but it started recognizing what was happening. And I think Microsoft probably was a little bit more in control of their destiny in these early days. And it was the Seagates, and it was all the companies that were providing the components. And so there was a real shift in the industry from a vertical world to a horizontal world. And I don't know, we could blame ourselves for not seeing it, but no one saw it. What we did try to do, I think, and everybody was in the program, even though the program wasn't successful, was to build some capabilities still aren't seen in personal computers. Real-time operating systems, responsiveness, user installability. You know, in many ways, I wish that we had won, because we really had some really good ideas, but we weren't able to win. And there were some histories of the company and the way the company was managed, and the fragmentation of engineering resources and manufacturing resources. And Barry and I were particularly pitted against each other to try to compete. And the competition was viewed really, it doesn't come across the movie, but the competition was really inside the company more than any other place. So those are my remarks. Barry, do you want to?
Yeah. I just want to add to what Avram said. We were very insular, as you can tell from the tape and stuff, and fighting amongst ourselves for critical resources within the company. But I thought I would relate a little bit, because I got to spend a lot of time on the phone with Bill Gates. I used to wake him up at 11 a.m. in Boston was 8 a.m. in Seattle, and he'd go to bed at 2 o'clock, and that was 6 hours of sleep, and I was living on 5, and I was older, so I figured that I could do that. And I'll tell you a couple of tidbits of historical, depending on your perspective. I have probably a Harvard case study of why we chose CP/M over MS-DOS. And I brought the reason with me. This is Digital Research's product called Concurrent CP/M. And it was a multitasking operating system. And of course, being at DEC, we had all kind of operating systems where multitasking was in our blood. And we didn't realize that the great unwashed didn't care about multitasking. And, you know, as I always said, if DEC had done DOS, we still wouldn't have shipped it. And I chased Bill around more conference room tables trying to get him to do a multitasking operating system. A little tidbit is he actually agreed to make MS-DOS 4.0 multitasking. I forgot to put greater than or equal in the contract, which is why I jumped from 3.5 to 5, just so you know. Okay, just so you know. And the he and I would fly and meet together in Chicago. He'd come from Seattle and I'd come from Boston. We typically meet on Sundays for strategy sessions and make that happen. He was very into reading books on database design. Another little tidbit is the Rainbow was originally going to be called CP/M. And I had to go out and fly out and get permission from Digital Research because they had the trademark on it and stuff like that. But Bill Gates convinced Ken Olsen that was probably not a very good choice of a name, just in case MS-DOS won. You'd want a little more flexibility from that perspective. Between 82 and 84, we decided in a meeting when it became clear that the industry had shifted to compatibles. And in the very first meeting I presented, the proposition of building a PC compatible was approved instantly with no debate, no discussion. Yes, go off and build a compatible just as fast as you can. So one of the things I had to do was fly out to Seattle, and I met with Bill, and it was a Friday night, and it was we were there all day and stuff, and this was about 8 o'clock at night. And I told him that we had made the decision to build a PC compatible. And he doubled over in pain. I mean, he just literally doubled over. I mean, he was leaning up against a conference room table, and he went like this. I mean, it was like that for about 3 to 5 minutes. And why he was in pain was he realized MS-DOS wasn't building a layer over the hardware, and that everything had to be hardware compatible, so he didn't really have a choke point yet. And this became very, very clear to him from that perspective. So let me turn it over to Gordon.
Right. I guess in terms of sort of what we had learned, the culture really was one of doing it all from bottom up, the special chips and everything, and to have the PDP-11 win in that environment was really an impossibility because DEC, in fact, I had gone to the mat many times on licensing the PDP-11 architecture. About 1979, after VAX had come out, I wanted to get rid of the PDP-11 architecture. I tried to give it to the government, or get them to ask for it because it was a millstone when we were into VAX, and to do that, but it was perceived that this was the corporate jewels. You couldn't let anybody make an alternative processor. So it really resolved, the whole fight there really revolved around the issue of standards and control. And so there was, in a sense, in retrospect, the guy who really opened that up was Bill in terms of making that, well, Intel on the component side of forcing it into all these things, because as a component supplier, they knew, gee, the last thing we want is a sole customer, just as suppliers don't want a sole, or hardware, they don't want sole sources. And similarly, Bill didn't really want to depend on a single vendor to do that, and had many ways of doing that. And so all of the papers you still read gee, wasn't IBM stupid to give up control of the PC architecture? And the answer is they had no option. They had nothing to do with it. I mean, if it hadn't been them, I believe it would have been somebody else. They were just forced to be the victim, called the victim of it. Because if they had had control of it, if they had controlled everything, no one would have followed it, and you wouldn't have had the thing evolve that. Look what happened when they tried to name a particular bus. All of the other people essentially said, "To hell," you know, I guess it was a microchannel. No, we don't want any of that mainframe stuff in there. We like it open this way, and we're an industry of ourselves with really 1,000 vendors. We want this form of standardization. So, in a sense, IBM couldn't have made that happen in the state the industry was at the time. Apple is a good case in point. Apple had control. They had an elegant architecture. Most of us still love Apples. They maintained control of hardware, software, all the layers, and that's why things generally plug together and work in such a simple environment. But the paradox is that it wouldn't have worked any other way. So the industry kind of had to come out this way, this what I call it the vertically disintegrated industry, which was or a horizontal industry. I left DEC in '83, so I won't take blame after this. And DEC, and I was still a stockholder at that point, and implored the organization to go open, because it was so clear at about '84 of hey, the game's over. It's a manufacturing distribution game. Yeah, you can still win at that, but it was. And by the way, I want to add one other point to the chart of what the differences are, and because I was at a large company today that makes, quote, enterprise systems, and it was, I won't say it wasn't one of the Vendrix companies, but it was, they did the three pyramid of mainframes, departmental. I said, yeah, I invented that pyramid diagram in '75. Yeah, I'm familiar with it. And they said, you don't understand. I said, what holds it is data inertia. There will always be a mainframe business. We can't get out of that. So people think that the IBM model would have worked. It would have worked if they could have gotten control and then had several alternative vendors, but it just it couldn't be created in that fashion. So anyway, let's open it up probably to other people.
I have a question as an old DEC fan and one of these people. The first timesharing system was just really on PP1 standard and on my tape. They had the best DEC tape and the best paper tape drive actually of all the DEC products. And I think that kind of leads to my question was, what did you really do when you were working on the PC design of DEC to talk to potential customers and people who are actually going to use the machine and choose the problems that they wanted to solve for?
Yeah, the question is,
it was irrelevant.
did we talk to any customers? Well, actually, we talked to customers on the CT or Pro side, because one of our objectives was to be compatible with VMS and to run the same, to go into the same market. On the business market side, nobody really talked to customers about the small business or consumer market, and I don't think it would have mattered if we had talked to first of all, it wouldn't change our behavior.
The market doesn't exist. When a market doesn't exist, you can't talk to those customers. The phenomena didn't happen in that way.
Well, my question is, because as a DEC fan, I really love the product DEC, but my first job where I had to make a decision on what computer to buy, it was the Xerox 515, which you may have heard about. Xerox failed the market. Wow. And the IBM PC. And with the IBM PC, or two IBM PCs, SuperCalc, WordStar, and one other program, a $2 million company was able to operate more efficiently than it had before. And that was the decision that understands the tools and paid for the printed letterhead. Right? So those are the kinds of decisions that really drove the computer market, this PC market. I mean, and I'm just surprised that even at this day, we're not doing that. The tape talks about simpler, easier, and so forth. Is that my note? I don't think so. So, you know, I mean, I'm just wondering what the background of all these development tasks really were that were looking at the realities of what the people were going to use the thing for.
Well, but you know, again, it was evolutionary. You know, IBM had, you know, was attempting to develop their own their own application software. Okay. I mean, this market evolved, and people started packaging software up together. The channels evolved organically. You know, it was a market experimentation, and it was learning in the market. And the fact is that the PC was so amazingly adaptable that the learning could be extremely fast. And so there were as many failures as probably in any industry, but there were also a few successes. And then people were able to copy the successes. And that's so it's really, you know, the best way to understand what happened is to be an anthropologist or to, you know, look at, you know, evolution.
I just think to add one thing. We ignored customers, to be frank about it. What do they know? We were DEC. In the Rainbow Group, though, we spent a lot of time talking to third-party software developers, and we got a lot of marketing sense from that, and a lot of knowledge of what was really going on. Let's get somebody else to, yeah, this person over here.
Could you sort of say a little bit about the three separate projects in terms of when each started and delivered, and then maybe a little bit about the sort of corporate background of each one in terms of what organizations they typically.
Sure. Gordon, why don't you answer that one, since you have that perspective?
Start in your house.
Yeah. Well, they all, okay, what was the organizational background and how did that all work? We had a thing called the Low End Group, and Dick Clayton, who's now a vice president at Adaptec, headed that. And Avram and Barry James and John Clark, who was doing the PDP-11, sort of all reported in there, along with terminals and printers. So it was all the sort of desktop systems things. And the issue of, so the 8 was clear because we had PDP-8 chips, and then we were just evolving that. But we were always fighting in a resource sense on that one of trying to cap it. Ken had visions of that running a small business, and I said, and the PDP-8 had which there are some around there, had a 32 12-bit 32 kilo word boundary, and it had the word processing program took about 33K, and it swapped and everything. And every time that we'd find a bug, why the fixing of that bug would create a couple more, and it was it had been out of gas for a number of years, and but it evolved, and it was a nice typewriter. But if we just had trouble keeping it that way of Ken wanting to really market it in a bunch of different ways. The issue of the Barry James project really grew out of putting an 8080 in a VT100. I don't know whether there's a VT100 here, but the VT100 was designed for putting, for building it would hold a whole computer in the side panel, and so he put that in there, and that was a character-generated terminal, and so we were, quote, in that 80 in the CPM market for a while, and so it was kind of a natural follow-on to build this other one. So we were really trying to figure out how we were going to win in that. So that was kind of, in a sense, a natural one. PDP-11 was one, quote, we're really going in the PC business. VAX wasn't ready yet to be as a single chip. It was too expensive, although in the film, which part got cut out, there was a very beautiful VAX terminal. If we had proceeded to move on that, it might have moved a lot further. It was a couple of years before Sun and Apollo had their stuff. But the thing that happened was that we were really trying to build our a first-rate PC from scratch, and that we knew about. We had the RT11, and actually RTX is what was really running on the system. And we thought we knew the users well enough in terms of what the interaction should be, but it was really the fact that the industry switched to an open one where everybody is out there doing it. I mean, every time I turn on my PC, I'm amazed that it works. I go to Redmond, I look at the testing process. It's thousands of different combinations. Literally, no PC can ever be tested truly because there's like 10 to the 200 combinations in that machine. I mean, a couple thousand different terminals, 20 or printers. All the modem combinations, all of the stuff can never be tested, and was not under control. IBM very early into the thing gave up architecture control. Microsoft was running to catch up, didn't know that you needed it. They just lie there, and when somebody says, "Hey, I can make a board that does this," and that's great, I want that board. Make sure you don't get in the way, because a random piece of software is going to go right through all the operating system and grab that bit and twiddle it. My friend Dave Cutler, who did NT, who built, he claims the first operating system for Microsoft. And I believe that's right. The others were a bunch of, I mean, if you look at his history of operating system, I think you'd say it evolved as a bunch of calls rather than an operating system. But the thing in doing that was the incredible difficulty of maintaining compatibility. That when he had NT, there would be, the people would do certain things like go in and some check certain parts of the operating system they could get their hands on to get a number so they knew what was going on. I mean, that's what applications programs did. So those were that was kind of the organizational environment. The other thing that happened during this whole thing was the marketing guys, this was the engineering side, and our manufacturing counterparts, we just sort of told them to build what we were doing. On the marketing side, we literally spent all the years where VAX was sort of taking off. This was like 79 to 82. All of the marketing committee, operations committee meetings were pretty much totally consumed with the marketing guys fighting over the bones of what were we going to do in the PC marketplace. There's a time when the classical thing where everybody wants to be known as being the hero. Well, after the PC thing, nobody wanted to be known, but the marketing people always wanted credit for. They were fighting about who's going to sell it, what do we do if we sell it and get credit for it, what's it going to do, and are we going to open more stores? DEC thought the key is opening computer stores. My God! Oh, and we opened. Yeah, John.
If I can just ask a question, then I'll share a story with you about DEC and compatibility. Tell me again, what was the time frame of the two films you saw? What years were those? The NCC was in.
That was 82 NCC.
When it rained inside. Or
yeah, right. Houston.
Yeah. Didn't work.
Yeah, and the second one was.
Oh, sorry, I got it.
December of '84.
Just if I can share with you a very funny story, I was at Xerox at the time, wrestling with the same problems. We had done the 820, which I will say is the first personal computer from a major office equipment company. It was, however, based on the Z80. And so we had that at 81 for about 3 months. We had the best machine around until the PC came out. And the PC came out and it sort of tipped everything over. We tried to figure out what the hell to do. And I stood up in the management committee one day, and we're talking about how we'd had the 820, we're going to do a follow-on, and we're going to do a real 16-bit machine rather than the half-breed 8088. We're going to do a real 8086, and we're going to have a unique operating system. And I got up and fought this, and the weapon I fought it with was a copy of PC World, which I think was like the 5th edition. And I said, look, the strength here has nothing to do with the machine. The machine's a piece of shit.
but it's this thing that has 500 pages of software, hardware add-on boards, quilted dust covers. I said, this is the problem that you got to solve. And my argument for solving it was to go try to find a clone. And there was the first pseudo clone, and then the first 2 real clones came out about this time. It's a trivia question. Anybody recall what they were? First pseudo clone that almost made it, but wasn't quite a pure clone, was Hyperion from Canada. And the first 2, well before Compaq, were Corolla and Corona. And so I pounded the table and said, look, goddammit, just go buy one of these machines, jam it through our manufacturing, we'll do a hell of a lot better. This is before Compaq.
Right.
No. We got to build something that's different and more unique and find something that'll really give us some distinction, some leverage. And by the way, somebody's talked to somebody at DEC, and they got these 3 great machines you got to go see, John. So we got on the airplane, and I was telling Gordon the story. We hauled ourselves up to Hanscom Field, got picked up by the helicopter, and we saw these 3 machines with 3 presentations, beautiful mechanical engineering, 3 different groups fighting with each other, and we walked out of them and we said, it's really nice to see another big company that's more screwed up than we are.
There's been a lot written about the CPM loss of the IBM market and what happened there that caused IBM to choose Microsoft instead. But from that point forward, do you think there's anything digital research might have done to come out better in the long run?
No, could not have. Bill Gates and I went to the Grill 123 in Boston one night, and we had a woman named Marilyn Darling who worked at Digital Research, and we had this conversation. And there was nothing they could do. IBM had set the price point for, I think it was called PC DOS at $60, and CPM was at $250. And even if they gave it away, there was no distribution for them to give it away. Today, you could put it on the internet and give it away and had a chance. But there was no distribution channel that was taking that. And the real battle was already won by the software developers. They had already cast their vote, and so you'd have to convince them to also port their software over. And they didn't have the capital structure to afford to do that. So they didn't have a chance. Well, the answer to your question, did they really have a chance? We thought at the time that they did. I'm giving you the historical perspective. Did they really have a chance? And with 20/20 hindsight, no.
But talking about how outcomes could have been different, I'll tell you, after I left in '83, March of '83, I went to Franklin Computer, where I was the president, because I was convinced that Barry had convinced me that things would be open, and actually we did about $100 million in our first year. We were going faster to Compaq, and we had a little problem with a company called Apple, and we tried to explain to them that if they would open the system and license us, this would be good, and the market would grow and it would develop and so on. And we even said, we'll be a licensee, we'll pay you money, and you can control the architecture, but we want to add some value to it. So that would have been a very, very different outcome. Having lost a little lawsuit, we didn't lose, but we didn't win with Apple. I tried to figure out what else to do, and I asked myself, who were the lawyers that defended Apple? And they were the lawyers that were defending Intel, so that's, anyway.
I have the memo that said let's license this thing and get rid of it. Yes, we had a discussion. It was one of the battles that I lost with my fellows at the executive committee, and one that I learned from was there was this thing called Ethernet, and I said, don't worry about a thing. It doesn't matter if we don't control it. It's just a wire. It'll have no impact at all on the computing. No, we don't want control. And besides, we don't have the patents either. And no, it's not something we want to have. We want control. So yes, we did. I had that discussion many times about openness. I'm actually a standards freak, whether it's the standards that come out from de facto by a manufacturer or a software vendor, or or whoever. But I think the world just moves very, very fast if you can aggregate around a small number of alternatives. Yeah, I think, yeah, a couple more. Yeah, two more. This one and that. Yeah, go ahead here.
I got a quick question and a slightly longer question. The quick question,
Yeah,
Gordon Bell never, not Gordon Bell, Ken Olsen never seems to have quite understood what software is. Did he ever quite
No, he didn't understand architecture either. So, and he doesn't like computers. So, I mean, there's a fundamental one. He really didn't, yeah.
Ken didn't use computers.
He hates them.
And basically, Ken was the packaging engineer actually on the project when we started, and
a superb one.
And
by the way.
probably the packaging was some of the best things that were ever done. He had a great feeling for the detail, and yeah.
Okay, then I had a second question, a little more complicated. You said earlier that there was a substantial not invented here, that you had to do the entire design yourself. But on the DECmate, I believe, you used an Intercell 6100 at the PDP-8. How did that work to go outside and bring in technology?
Oh no, those were all fine decisions because we had licensed and got Intercell to do it. When I came back from Carnegie in 72, I went to Intel and said, please take the PDP-11 and sell us chips. That's our PDP-8. We don't want to be in that business. And then we had the discussion later on the PDP-11 with National. We could have done that deal. But it was, nope, we don't want control, we don't want to give up the control. It really was a stupid control issue, ill-defined.
Was that, yes.
Yeah.
Last question.
I vaguely remember there were some internal kind of bootleg projects to build PC-like things inside DEC in the 75, 76, 77 time frame. There was Rick Merrill, a project called Snacky, the smart keyboard.
Yeah, we had that, yeah. And I think it actually made it to the market.
Yeah, it was GT.
GG, was that GG?
Yeah. And there were all kinds, there was a components group that used to be selling QBus products and others and terminals, and they roll and
we had so many, we had 30 terminals at one point for different things, and I ran central engineering, which was sort of the bulk of the engineering, but there were these market product lines, and every one of them had to do something themselves. And Ken came to me and said, you've got to get control of these terminals, and there are only 30 different kinds, with different colors. And
the famous story is Dan Bricklin, probably people know this, that he wanted to start doing VisiCalc on one of these terminal products.
Yeah. Right.
I forget what DT something or other, and then he wasn't able to buy one from. So the only thing he could get a hold of was the Apple II, and that's where VisiCalc got started.
Yeah, that was right. There are all these little things that were big turning points that could have changed.
Yeah.
Particularly, I think the VisiCalc story is a great turning point.
So, well, I think we're going to stop now.
Yes.
And people will be around. We thank you very much for your attention.
Okay.
So I got my PDP-8, I got a dual deck tape prize and a cartridge. Now what do I need for some of this computing stuff of yours? You guys keep talking about it. I've assembled the equipment. It's taken me years. Now what do I do?
What do you mean?
My junior high school bought an EduComp PDP-8 system, and I bought it from them a few years ago.